Hello everyone. Again, welcome back to Embed System course. So we are in chapter number 1, that is 8051 programming in C, and in lecture number 5. So uh, in last lecture, that is lecture number 4, we discussed about how to perform logic operations for 805 microcontroller in a C programming language. In this chapter, we are going to focus on data conversion programs in C for 8051 microcontroller. Okay, so under this we are going to study how to convert packed BCD number to ASCII, how to convert ASCII to packed BCD, how to convert binary to decimal or ASCII, and in the last we will study what is a checksum byte and how to calculate checksum byte and what is its application. Okay, so data conversion simply means converting data in one form to other form, or in other words converting data from one number system to other number system, or converting data in one form to the useful form. Okay, so according to that there might be n number of such conversion, but out of that we are going to study only a few which are important to us. So before proceeding towards first point, that is packed BCD to ASCII conversion, let us revise what is this packed BCD. Okay, so I will use pen tab. Okay, so first, uh, what is BCD? Okay, so BCD means binary coded decimal. Binary coded decimal. Okay, so BCD actually is what it is. A decimal. It is representing decimal number, but it is coded in binary. That is the meaning. Okay, so it is a number means, and it is a decimal means unique decimal numbers possible are 0, 1, 2, and up to 9. These are the symbols, unique symbols available in decimal number system. Okay, and what is binary coded decimal? So these decimal numbers are coded in binary. Okay, so how many bits are required to represent these numbers? So this is the highest number. Okay, 9. So to represent 9 we require 4 bits. Okay, because in binary if we convert 9, then it will be 1 0 0 1. Okay, means 4 bits are required to represent 9. So in BCD format, each decimal number will be represented by using 4 bits. So 0 will be represented as 0 0 0 0, 1 will be represented as 0 0 0 1, 2 0 0 1 0, and so on, and up to 9 1 0 0 0. So these are BCD numbers, that is binary coded decimal. Okay, so I think concept of BCD number is clear now. Now there are two types of BCD numbers. Okay, first is for example we will take first unpacked BCD numbers, and second is packed BCD number. Okay, now so these numbers uh, 0 to 9, these are the BCD numbers. Now suppose 8 bit format is used to represent BCD number, any BCD number. In that case, to represent 0 I will use 8 bits. So 0 BCD number can be represented as 0 0 0 0 and 0 0 0 0. Okay, so in hex it will be 0 0 H. Okay, now this represents BCD number 0. Similarly, BCD number 1 can be represented as 0 0 0 0 0 0 0 1. Okay, So this is BCD number 1. Okay, in hex it is 01H. So this is BCD number 0, this is BCD number 1. BCD number 2 can be represented as 00000010, and so on. I can represent 9 as 00001001. Okay, now see here, out of 8 bits, only lower 4 bits, that is lower nibble, is utilized to represent this BCD number in this 8-bit format. Okay, means remaining 4 bits, that is upper 4 bits, are always unutilized here. Okay, so this type of representing BCD number is called as unpacked, because all the bits in this 8-bit format are not packed with BCD number. Upper 4 bits are always vacant. Okay, so by using this 8-bit unpacked BCD number, I can represent only one BCD digit. Okay, that is unpacked. Now in case of packed, uh, suppose I want to represent 32 by using unpacked. For 3 we will require 8 bits. Okay, and for 2 we will require 8 bits. Okay, 3 can be represented as 00000011, and 2 can be represented as 00000010. So this is unpacked. Okay, 32 to represent it 32 BCD number, we require 2 8 bits, isn't it? So these are unpacked, means this upper 4 bits or upper nibble is not packed with BCD number. Okay, now instead of using these 2 8 bits to represent these 2 digits of BCD number, okay, I can use only one 8 bit. Okay, how? So upper digit or upper BCD number is represented by upper nibble, that is 0011, and this second BCD number in lower nibble 0010. Okay, so 32 can be represented by only one 8-bit number, in which lower nibble represents 2 and upper nibble is BCD number for 3. Okay, so here this type of BCD number is called as packed, because all the bits in these 8 bits are packed with BCD number. Okay, so upper nibble represent one BCD number, and that is 3, and lower nibble represent second BCD number, that is 2. Okay, so such a representation is called as BCD, packed BCD. Okay, so that is the difference between unpacked and packed BCD number. Okay, now let us go to the next slide. Now before going to actual conversion programs, see this table. So now this first column represents the key, okay, number key, okay, which ranges from 0 1 2 3 up to 9. Okay, so these are the keys that are available on the keyboard of your embedded system, or you can imagine the keyboard of your computer system, in which there are keys for these numbers. Okay, so what will happen when you actually press a particular key? So when you press a key, then your computer system, or whatever system is there in keyboard, it will send the ASCII code of this key to your uh, microprocessor, and it will get displayed on the application which is rightly active on your desktop. Okay, so in this way, when particular key gets pressed, its ASCII code is actually sent to application. Okay, so this is one application converting the key to ASCII code. So here these are the keys 0 to 9. Okay, we are concerned with only BCD number, so we have taken these number keys 0 to 9. So 0 is having ASCII code 30. So ASCII code means American Standard Code for Information Interchange. Okay, so ASCII code is normally of 7 bits. Another type of code is also there, developed by IBM, and that is EBCD code. Okay, so ASCII code, American Standard Code for Information Interchange, which is one standard. Okay, so it is 7 bits. 7 bits code means each key on keyboard. Okay, so that key could be numeric key or alphabets, capital, small, or any other characters. So each key or each character or each letter is, or each symbol is assigned with one standard code, and that is called as ASCII code. Okay, so you can easily find these ASCII codes when you search on Google. Okay, so in that this zero key zero key is having ASCII code 30. One is having ASCII code 31. So these 30, 31, 32 are written in actually hex. Okay, so these are hex number, hexadecimal number, means ultimately binary. When you convert it to binary or binary coded, if you code it in a BCD, it will become 0011. So this is actually packed BCD. Okay, packed BCD representation of this ASCII code 3030. So 3 will be converted to one BCD number, and 0 will be converted to another BCD number in 4 bits format, and both are packed together in 8 bits, that is called as packed BCD. So 3 here 0011 and 00001. Okay, and this key 0, its binary representation is, sorry, uh, 0000000. So in this way, all the keys are having these ASCII codes ranging from 30 to 39. Okay, and it's BCD code. Okay, so 30 is having BCD code, packed BCD code 0011 0000. Okay, so what is our objective? Our objective is to convert, okay, these ASCII code uh, to BCD code, or BCD code to ASCII code. Okay, so these are the ASCII codes. Another code that is used in IBM PCs are ABCD codes. Okay, so ABCD means extended binary coded decimal uh, for information interchange. Okay, so it is actually 8 bits. It is actually 8 bits. 7 bits means I can use 128 unique combinations of 7 bits, means I can represent 128 characters, symbols, numbers, or letters by using ASCII code. But here one more ASCII code type or extended version of ASCII code is available, that is called as extended ASCII code, which uses, instead of 7 bits, which uses 8 bits, so that 256, okay, so 256 symbols, letters, or characters, or numbers can be represented by this extended ASCII code. EBCD is originally 8-bit ASCII code, so that we can represent maximum 256 letters, characters, symbols, or numbers by using this EBCD code. But this one is popular now. Okay, that is ASCII codes. Okay, so that's why these are used. Now we will move forward. So first mm, we will see this. Sorry. So first we will study this packed BCD to ASCII conversion. Means packed BCD number is given and we have to convert it to ASCII. Okay. So see here. Uh, so here this is packed BCD number, that is 2929. Okay. So if we unpack it, means if we convert it to unpacked BCD, means here in 8 bits, 2 BCD numbers are there. 2, that is 0010. So this is hex number representation. So first BCD number is 0010, that is 2, it is representing decimal 2, and second BCD number, that is 1001, it is representing decimal 9. So this is packed BCD number. Okay, so this is This is packed BCD number. Okay, so its hex representation is this 0x29. Okay, so if we convert this 0x29 or 00101001 BCD number to unpacked BCD number, okay, that means to represent 2 we have to use 8 bits, and to represent 9 we have to use another 8 bits. So here 0x02 is representing BCD number 2, that is 0010. Okay, and 0x09 in hex, that is representing BCD number 1001. So upper 4 bits are vacant here, are unpacked. So this is unpacked BCD representation of two BCD numbers, that is 2 and 9, hex 2 and 9. Okay, so this is one unpacked BCD number, this is another unpacked BCD number. This is representing uh, decimal 2, and this is representing decimal 9. Okay, now when we convert this unpacked BCD number, so to convert this packed BCD number to ASCII code, what we have to do, we have to convert ASCII code of 2 and then ASCII code for 9. ASCII code of 2 is 32H or 0x32, and ASCII code of 9 is 39H or 0x39. Okay, so ultimately if I give input to program packed BCD number 29, what I should get? I should get 32 and 39 as ASCII codes of this packed BCD number. So first we have to separate these two BCD numbers in unpacked BCD number, like 0x02 and 0x09. Then this 0x02 should be converted to ASCII code, its ASCII code, that is 0x32, and then we have to convert 0x09 ASCII code for 0x09, that is 0x39. That is the objective. Ultimately in the end we should get these two numbers. So this is representing actually 0x32, this is representing 0x39, which are ASCII codes for 2 and 9 in this packed BCD number. Okay, so that is the objective. Now program is written for that. So write an 8051C program to convert packed BCD 0x29 to ASCII and display the bytes on port 1 and port 2. ओके, म्हणजेच काय करायचं आहे, हा बीसीडी नंबर 0x29, ओके, त्यामध्ये दोन बीसीडी नंबर्स आहेत. ओके, सो फर्स्ट that is 2 and second 9. Okay, 2 means 0010 BCD number, 9 means 1001, because this is hex. If we convert this hex to binary, okay, or yes, binary, then I will get 00101001. So this is representing decimal 2 and this is representing decimal 9. So this is a BCD representation of 2 and this is a BCD representation of 9. Okay, so we have to convert these two BCD numbers to their ASCII codes. That is ASCII code of 2 is 32H and ASCII code of 9 is 39H. That is the objective for which program is written. Now see here, and we have to output this 32H and 39H to port 1 and port 2. So the program is written very simple. Hash include reg51.h void main void. I'm declaring three variables x, y and z. Okay, by using this first declaration statement. Unsigned char means data type is unsigned char and variable names are x, comma, y, comma, z and semi-comma. So this declaration statement will declare x, y and z as unsigned char type of variable. Okay, that means I can store in these variables x, y, z, I can store value, any value in between 0 to 255. That is the meaning, because data type is unchar, unsigned char. Okay, next is also declaration statement. This is again declaring unsigned char type of variable and its name is mybyte. Okay, mybyte is being declared as unsigned char type of variable. That means in mybyte I can store value in between 0 to 255. Okay, and that value we are assigning here 0x29. Okay, so here while assigning value I can assign it any number system. So here number system is used as 20 hex number system. 0x29 means this number is hexadecimal number. Here I can also write directly number. For example, what is difference between my byte is equal to 0x29 and my byte is equal to simply 29? Okay, difference is if I write 0x29, that means it is a hexadecimal number, and if I write 29 means it is a decimal number. So that decimal number ultimately get converted to binary, and that will get stored in my byte internally. Okay, and here hexadecimal numbers means it is actually binary, means 0010 and 1001, that will get stored in my byte. In this way, in any variable in C programming language, I can store data in any number system. Okay, so how for that I will explain it in next lecture, how to uh, assign value in various number system to a variable. Okay, so here this second declaration statement is declaring my byte as a unsigned char type of variable in which I am storing number 0x29. Okay, next x is equal to my byte ampersand 0x0. Okay, so my byte मध्ये काय आहे? So in my byte, what is data? That is 0x29. That means 0 0 1 0 1 0 0 1, and this is single ampersand, means it is a bitwise AND operator, and we are ending this 0x29 with 0x0f. 0x0f means 0 0 0 0 1 1 1 1. So what will happen? Ending operation, 1 1 produces 1, 0 1 produces 0, 0 1 produces 0, 1 1 produces 1, and remaining bits will be 0, because anything ended with 000 produces 0000. So this number is in hex 0x09. Means what we are doing, we are taking first only this BCD number 9 for processing. Okay, so we have masked these upper 4 bits and we have removed these 2. Okay, now what in x, what we have in x, we have 0x09. In x variable I have 0x09, then that x. Okay, now next statement is p1 is equal to x bitwise OR. This bar means bitwise OR. It is ORed with 0x30, means this whatever value in x which is now 0x09, that is 00001001, it is bitwise ORed with what? 0x30. Okay, so 0x30 means 00110000. Okay, so that will be ORed, so it will produce 1 101 000 000 101 011 011 0000. So it will produce 0x39. Okay, and 0x39 is what? It is ASCII code of 9. Okay, and that we are outputting to port 1. That means one part is finished. What we have done, we have converted this BCD, first BCD number, that is 1001, that is 9, to its ASCII code, that is 39, and we have outputted it to port 1. Okay, now second number, so let me erase it. Okay, so now second number, so second number, so here y is equal to my byte ampersand 0xf9. So what is in my byte? My byte is having 29, 0x29, that is a packed BCD number. So we are ending it bitwise, ending with what? 0xf0. Okay, so my byte is what? That is 0 0 1 0 1 0 0 1. And what is f0? 1 1 1 1 0 0 0 0. That means simply we are masking these uh, four lower bits. Okay, so and this ending operation produces 1 0 0 0 0 0 0 0 0 1 0 0. So this 0 1 0 1 1 1 0 1 0 and 0 1 0. Okay, so this will produce 0x20. So y will have value 0x20 after this. Okay, my byte bitwise and with 0xf0 means we are just taking now next BCD number 2. Okay, because already we have converted this 9 to its ASCII code, that is 0x39, and we have outputted it to port 1. Okay, right now what we have to do, we have to now take this second BCD number and convert it to its ASCII, that is 32H, and we have to 32H or 0x32, and we have to output it to port 2. Okay, that we are doing. First we are masking this lower BCD number, that is 9, and here simply we have 0x20. Okay, then y, that value is available in y. Now what we are doing, we are y right shift by 4 position. Okay, and then whatever that value we will get, that we will get assigned to again y. Okay, so when this number shifted 4 times right, what will happen? I will get 0 0 0 0 0 0 1 0. That is, I will get 0x02, means I have just shifted this to lower nibble. Okay, and upper nibble will get filled with 0 0 0 0. Okay, means just I am taking this to upper nibble to lower nibble, so that I can convert this number to its, that is 2 number to its ASCII code. Okay, now that value I will have in y, because ultimately after shifting to left by 4 position, again I am assigning that to value again to variable y. So what is in y now? 0x02. So next is y is bitwise ORed. This is OR. Bar means OR. So whatever content in y, or bitwise ORed with 0x30. Okay, so what is 0x30? That is 0 0 1 1 and 0 0 0 0. So there will be bitwise OR operation between these two uh, datas, that is these 8 bits and these 8 bits. These 8 bits are available in y, and these 8 bits, that is 0x30, directly specified in the statement. So there will be bitwise OR operation. 0 0 produces 0, 1 0 1, 0 0 0, 0 0 0, 0 1 1, 0 1 1, 0 0 0, 0 0 0. So this will produce, what is number this is 3 and this is 2. So 0x32 or 32H, that will get produced, and that we are outputting to port 2. Okay, so what is 32? 32 is nothing but ASCII code of 2, isn't it? Okay, so what we have done, so we have this my byte 29, that is BCD number. Then objective is to convert this BCD number to ASCII codes and output these ASCII codes to port 1 and port 2. So first we derived ASCII code of 9, that is 39, and that we have outputted to port 1. Then we derived ASCII code of 2, that is 32, and we have outputted to port 2. Okay, so that is being asked in the statement. Next, ASCII to packed BCD conversion, that is opposite. If the ASCII code is given, then how to convert it to its BCD format. Okay, for example, suppose this key is 4. Sorry. So key is 4. Okay, 4 4 7 47. Okay, so 4, it is having ASCII code 34, and 7 number key is having ASCII code 37. So its unpacked BCD conversion is that is uh, key number 4. Okay, its unpacked BCD conversion is 00000100, and for 7 number key its unpacked BCD is 00001111. Okay, so ultimately what we want 47. If these two keys are pressed 4 and 7 keys are pressed, okay, ASCII code of 4 is 34, ASCII code of um, 7 is 37, so we have got 34 and 37. So we have to convert these ASCII codes to packed BCD. Okay, means in upper nibble it's this uh, this 34 is representing BCD number 4 and its BCD representation is 0100, and 37 representing decimal number 7 and its BCD representation is 0111. So this will produce packed BCD 01000111, that is in hex 0x47. Okay, so this is a what we want, that is packed BCD number, ultimately packed BCD number. Okay, means when key number 4 and 7 are pressed, suppose key number 4 and 7 are pressed and its their ASCII codes are available 34 and 37. Okay, we are assuming that two ASCII codes are available 34 and 37. What we have to do, we have to produce its packed BCD number, that is 0x47. Got it? So this is the task. So for that, program is written. So write an 8051C program to convert ASCII digits 4 and 7 to packed BCD and display them on port 1. Okay, so as I explained, first I am including reg51.h file in my program, and then okay, so then void main void function. So first declaration statement is declaring BCD byte. So BCD byte is the name given to variable and it is of type unsigned char, means in BCD byte I can store any number in between 0 to 255 in decimal. Okay, or 00h to ffh in hexadecimal, or in binary 00000000 to 11111111. Okay, so this is BCD byte variable of unsigned char. Then next is also declaration statement. I am declaring w as unsigned char variable, and w is equal to in single quote 4 semicolon. Okay, so this single quote in a single quote 4 means it is representing single character. Okay, so what will happen when this declaration statement executes? So what will happen, w will be declared as unsigned character, means it can hold value in between 0 to 255, and in w I am to this w I am assigning this character 4. So actually what will happen, what value will get assigned to w, then this single character, this represents in single code whatever enclosed in single code that represents character. Okay, so what will happen, so when we assign any character to this variable w variable, then its ASCII code will get stored in w. म्हणजेच काय, in a w what will get stored, ASCII code of 4, that is 34h value will get stored. 34h in hexadecimal I am saying. 34h is the ASCII code of 4 that will get stored in w. Third declaration statement is unsigned char z is equal to in single quote 7 semicolon. So this declaration statement is assigning ASCII code of 7. Okay, so what is ASCII code of 7? So in single quote means it is ASCII code of 7, that is 37. So 37h will get assigned to variable z. Okay, so what we have in w and z, ASCII codes of 4 and 7, that is 34h and 37h. We have to convert these to packed BCD. That is the objective. Now next, see, w is equal to w ampersand 0x0f. Okay, so what will happen? So W is equal to W ampersand 0x 0f. So W, in W what we have, that is ASCII code of 4, that is 34H, that is in binary. 34H in binary means 0011 and 0100. It is being ended, bitwise ended with 0x0f. So 0x0f means 0f means 0000, and 1 means f means 1111. So bitwise ending operation produces 010 010 111 010, and remaining 4 bits will be 0, because anything ended with 0 is 0. So it is producing 0 4. Okay, so 04H will be there in W. Okay, so then what we are doing, W is equal to W left shift by 4 position, means this data available in W. Okay, in W variable what is 00000100. So if we shift this data towards right by 4 position, left, towards left by 4 position, what will happen? So this lower nibble will get shifted to the upper nibble position, means here I will get 0100 and 0000, that is 40H. Okay, means what, we are just shifting this number to this position. Okay, and here we are putting 00. Okay, so this thing will happen. So that means what is available value in W मध्ये काय आता, that is 40H. Okay, now next, Z is equal to Z bitwise and with 0x0f. आता Z मध्ये काय value आहे, we have ASCII code of 7, that is 37 is in Z. Okay, so this operation Z we have 37 means 0011 0111. It is bitwise ended with 0f, means 0000 1111. So this will produce 111 111 111 010, and remaining bits will be 0, because anything ended with 0 is 0. So this is number 07H, that will be available in Z. Okay, so Z will be 07H. Okay, now BCD byte means produce packed BCD byte. Okay, that we are storing in BCD byte variable is equal to W odd with Z. Now what is in W? W मध्ये काय आहे? Here W 40 means 40. W मध्ये काय आहे? 40, and Z, what we have in Z, that is 07. Both are in hex. Okay, now there is a ORing operation, bitwise OR operation. Okay, uh, bitwise OR operation between Z and W and Z. So W, that is 40, that means 0 0 1 0 0 and 0 0 0 0. 7 means 0 0 0 0 0 1 1 1. So in these 2 bytes, in between these 2 bytes, there will be bitwise OR operation. Okay, so this will produce 0 1 1 0 1 1 0 1 1 0 0 0 0 0 0 0 1 0 0 0 0 0. So sorry, here 101. Okay, so this will produce 4747H. Okay, so that will get stored in BCD byte. So what is 47 actually? 47 is actually packed BCD conversion of these 4 and 7 ASCII digits, isn't it? Okay, so these ASCII codes in W and Z, that is 34, which is of 4, and 37, which is of 7, we have converted to packed BCD number, that is 47, and that 47 we are outputting to port 1, because that is been asked, that is uh, convert ASCII digits 4 and 7 to packed BCD and display them on port 1. So here we are displaying 47 on port 1. In this way we can convert ASCII to BCD, packed BCD. Okay. So next conversion is binary to decimal or ASCII conversion. So for that, there is a facility in a C programming language. By using this, I can directly convert binary to decimal. Okay, so printf function for that we can use from stdio.h header file for conversion of data from binary to decimal or decimal to binary. Okay, by using particular conversion characters. But printf function takes a lot of memory space and increases the size of hex file. So it is better to write your own conversion function instead. Okay, so it is bad idea to use a inbuilt printf function from stdio.h file because it will take a lot of memory space. Okay, and it ultimately increases the hex file to be written on program ROM of target device, that is microcontroller. Okay, so instead of using this ready-made printf function, we can write our own conversion function for that, that is to convert given binary number to decimal or decimal to binary. Okay, so in many cases we need to display binary data, we need to convert it to decimal and then to ASCII. Okay, म्हणजे एम्बेडेड एखाद्या एम्बेडेड सिस्टमला तुम्ही whatever commands you will give or whatever that binary embedded system will display on its display, so it will be in ASCII. Okay, so for that whatever binary internal binary numbers we have to ultimately convert to either decimal or ASCII so that it can be displayed properly on the display of embedded system, that is the application. So here is the program. This program is written to convert 11111101, that is FD in hex, FD to decimal and display the digits on port 0, port 1, port 2. ओके, तर हा प्रोग्राम काय करतोय तर त्याला एक बायनरी नंबर दिलेला आहे, बायनरी इन हेक्स फॉर्मॅट. ओके, so you can input in binary or in hex in this program, and that we have to convert decimal. For that program is written. Okay, so see here, include reg51.h void main void in void function. This is a first declaration statement. Unsigned char. Okay, we are declaring 1 2 3 4 and 5 variables. Okay, so these variables names are x bin byte d1 d2 d3. Okay, and these are of type unsigned char, means in each variable I can store a number in between 0 to 255. Okay, now I will just tell uses of these variables d1 d2 and d3. Okay, so these three variables are used to store converted decimal number. Okay, digits of converted decimal number. So maximum decimal number could be 255. Okay, and minimum 0. Okay, that we are assuming because this 8-bit, any 8-bit binary number can convert value in between minimum 0 to maximum 255. Okay, means it could have maximum 3 digits decimal number. So to hold this decimal number, I have declared here 3 variables d1 d2 d3. Okay, and remaining two variables are used for programming for temporary storage. So first, this bin byte number is used to store binary number to be converted to decimal. So see here, next statement, bin byte is equal to 0xFD. Okay, means the number to be converted to decimal that is given in the program statement, that is FD 1111111101. So that I am storing in bin byte. Then x is equal to bin byte divided by 10. Okay, now I will use pen tab. So here x will get divided by 10. Sorry, bin byte will get divided by 10. So what is value in bin byte? That is FD. FD means in decimal if we convert FD. Okay, what is the value? I think it is 253. in decimal. FD in hex, if we convert to decimal, it is 253. We are dividing it to 10. Okay, so these two numbers are integer numbers. Okay, so there will be integer division and value will get stored in X. Okay, so actually this will produce actual exact answer 25.3 if we divide 253 by 10, but only integer part of this division 25 will get stored in X, because X variable type is unsigned char, means it can hold only integer value. So 25 will get assigned to X. Okay, that means X we have, after this statement, X will have 25. Then D1 is equal to, see, D1 will be equal to bin byte percentage 10. So bin byte is what? 253 in decimal. Percentage means it is a remainder operator after division. So 253 will get divided by 10. Okay, and whatever remainder, that means after division of these two numbers, remainder will be, it will be 3, and it will get stored in variable D1. So D1 will have 3. Okay, now next statement, D2 is X percent 10. What is in X? X is having value 25. So 25, then remainder operator percentage 10. So 25 will get divided by 10, and whatever remainder. Okay, so this X percent 10 will produce a remainder after division. So after dividing this 25 by 10, remainder will be 5, and that will get assigned to D2. So in D2 what we have 5. Okay, then next D3 is equal to X divided by 10. X, what we have, X 25. So 25 simply get divided by 10. So what we will get? So actually answer we should get 2.5, but here this is integer division, and integer division produces integer number only. Only part of this fractional number, integer part will get retained, and that will get assigned to D3, that is 2. So in D3 we have 2. Okay, now if I arrange this D3, D2 and D1, okay, so D3 is having 2, D2 is having 5, and D1 is having 3, 253. Okay, so what is 253? Actually this, if we convert this FD, okay, if this FD number we convert to decimal, answer is 253. So that answer right now we have in D1, D2, D3. D1 is the lowest significant digit of that decimal number, D3 is higher significant digit of that decimal number, and these numbers, or this decimal number 253, we have to display on port 0, port 1, port 2. So on port 0 I will display D1, that is 3, on port 1 I will display 5, and on port 2 I will display 2. Okay, so this is the way we can convert a binary number to decimal. Exactly opposite procedure we can do to convert a given decimal number to binary. Okay, so in this way we can convert binary to decimal and decimal to binary. I think we will continue the next part, that is checksum byte, in part 2 of this lecture number 5. We will stop here. If any doubts in this part, we will discuss in live session. Okay, thank you.